Hi everyone, my name is Ranger Claire. It's lovely to have you all here today. How's the volume level? Good? Good. This is some new equipment for us this year, so I like it. Helps preserve the voice, so always a plus. My question for you all, whose first time is it visiting Bryce Canyon? First time? Yeah, very cool. Well, welcome. And has anyone been to Bryce Canyon before?
Yes.
Well, welcome back to you all. Very nice. So, a couple quick reminders for hiking at Bryce Canyon. Anyone notice that just walking very briefly, it's sort of a little bit harder to breathe here? Yeah, that's a fun fact that happens at 8,000 feet elevation where we're standing. It is quite a lot less oxygen than what you might be used to elsewhere. So any of these hikes that you go on today, remember to still bring plenty of water and eat salty snacks. Those are things that can help with the high elevation. Another thing, fortunately, we shouldn't have to worry about today, lightning on a high plateau. That's something if you're traveling more in the summertime, keep that as a reminder. But again, looks like these little lovely puffy clouds shouldn't do too much harm today. So I have worked in the Park Service since 2018. This is actually my 5th season as a ranger now. And I love my day job of working in beautiful places like this. But in my spare time, I also really like to bake. Any fellow bakers in the audience? Anyone just like to eat what other people bake? Nice. Yeah, so when I first came to Bryce Canyon, I did what about 2.5 million people do every year. Looked over the edge and just thought, wow, what an incredible place. I had never seen anything like this before, and as I started researching how this was all made, I realized I could combine two of my passions. So today we're going to learn why Bryce Canyon has the perfect recipe for making a hoodoo. And now, as with most recipes, we need to start with our ingredients. Any guesses for what ingredients go into making these rocks, the hoodoos? And you can yell it out. Limestone? Sandstone? Sandstone. Yeah, so sandstone, that's what I first thought this was. I worked in Moab in 2020, so when I got to more red rocks in Utah, I assumed red sandstone. There is some sandstone that goes into making this, but actually most of it's going to be limestone. So that's something to think about. Any other guesses for ingredients?
Iron.
Iron, absolutely. That's where we're going to get into that red color. Iron.
Magnesium.
Water. Magnesium, nice. Did I hear water? Water? What did
Magnesium. Yeah.
Nice. Calcium, that's what not a lot of people get, yeah. And specifically calcium carbonate will play into this. Very good. So yeah, those are definitely some key ingredients for making the hoodoos, the ingredients of Bryce Canyon. There's one primary ingredient that not a lot of people guess, and if anyone did guess it, I would probably just hand over my whole program to them. That would be ancient lake beds. So if we rewind about 58 million years ago, Bryce Canyon was a much different looking place. So different that we were at about sea level in elevation and also would have been partially underwater. This was the site of an ancient lake. It was called Lake Claron. It spanned 250 miles long and about 70 miles wide. That's about the size of modern day Lake Erie. However, Lake Erie is closer to 200 feet deep, whereas Lake Claron would fluctuate between 15 and 25 feet deep. So it was basically a giant freshwater puddle. That's what we were working with. And because of its shallow depth, we had seasonal cycles of evaporation and deposition. So what would happen is during the rainy season, the monsoons would come in, you would have the surrounding mountain streams flow down into this low-lying basin where the lake was. They would deposit their various sediments down there. You would also get little snails and algae that would live in the lake. And then the dry season would happen, and a lot of that would then dry up. These new sediments would be exposed to the oxygen, and you would also have the algae mats and the snail shells being left behind as well. Next year, more rainy season, new sediments deposit on top of the old ones, and it was this cycle repeating itself for 25 million years that eventually the combination of sediment, pressure over time, and the organic material went from Lake Claron to the Claron Rock Formation. And so that's what all these pink and white and yellow colored rocks, these are made up of the Claron Rock Formation. And currently that formation is about 700 feet thick. So that sort of goes to show just how long the lake bed was stacking up. Now, this was occurring primarily at sea level and elevation, but now we're at 8,000 feet in elevation. Any guesses for how we got up here? Tectonic, exactly, tectonic plate shift. So a couple things can happen when the tectonic plates move. And just like baking, we need our heat. So 28 miles below us, the Earth's mantle runs 1,000 degrees Celsius, which is about 1,800 degrees Fahrenheit. And those high temperatures cause thermal convection currents. And the tectonic plates shifting and floating on top of there move with that heat. Now, you can get a convergent plate boundary. That's like Mount Everest and the Himalayas, where the plates were pushed together and forced up to higher elevations, but the rocks were also deformed in this process as they're sort of squished and crunched together. You can get a transform plate boundary. That's where I'm from in Southern California, mostly earthquakes occurring in this area. And you also have a subduction plate boundary. Oftentimes we think about volcanic activity in this area, but something pretty unique occurred for here at Bryce Canyon. We had the ancient oceanic Farallon plate that came out of the Pacific Ocean. It subducted underneath the North American continental plate at a much shallower angle and faster rate that sort of just pushed up this interior segment of the continent that we now call the Colorado Plateau. And the Colorado Plateau is 240,000 square miles that was uplifted and kept relatively intact horizontally. So unlike Mount Everest, where those rocks were pushed together and the layers shifted, this Colorado Plateau uplifted and was able to keep the rock layers as they were deposited intact. So that's a really cool thing for geologists to study out here. And if we look across here at the canyon, you can watch and follow these horizontal lines from one rock to the next. We sort of call them bathtub rings, but it's basically the deposition and shows how the uplift was kept intact, since you can follow these lines from one rock to the next. So we had all of our ingredients deposited in the mixing bowl of Lake Claron, and then we had our tectonic plate uplift, baking and rising the rocks up to this 8,000 feet in elevation. And so next, we need to carve into our geologic cake. Any guesses for how you carve a geologic cake? Erosion, exactly. Sort of a stretch on the pun, I realize, but I'm glad you all followed along with me. So here at Bryce Canyon, there's primarily two types of erosion and weathering that are taking place. You have physical weathering and chemical weathering. Maybe I'll start with physical, because I have something kind of fun for chemical weathering, and then I don't want the physical weathering to sound boring. So we have here at 8,000 feet a lot of temperature fluctuation. So in fact, 170 days of the year, temperatures go both above and below freezing in the same day. What happens then, any moisture that's trapped in the rocks when temperatures freeze at night, that freezes and expands. This is called frost wedging. It acts like a geologic crowbar, breaking the rocks apart from the inside out. And so it's that physical force, that's the physical weathering element. And then next we have our chemical weathering. So that's what I have a little example here, and I can walk around with this. Step 1, safety, gloves. So, as I mentioned before, this rock is coming from an ancient lake which had those snails and algae, the organic material contributing to it. So that left behind what we call calcium carbonate, and that is a key element in limestone. So something that's cool that happens with limestone and calcium carbonate, anytime it rains, the rainwater picks up a little bit of carbon dioxide in the atmosphere. That forms a weak carbonic acid. And when that acid interacts with the limestone, it bubbles and fizzes. And so what I have here is hydrochloride, and it's 10%. So it's stronger than just your regular rainwater, but it's gonna sort of produce a cool effect. So, and I just put a couple drops on. Do you see it like bubbles? And so it's the bubbling and fizzing when the rainwater interacts with these rocks here. And it's pretty cool. This rock isn't treated in any way. So eventually it does make a hole over time. And that's why, yeah, we don't do this on the real rocks out here because I don't want to pick up the erosion anymore. But yeah, so when it drops,
So we talk about acid rain now. I'm not sure if that's acid rain.
yeah, so there's a question about acid rain and pollution. And so that's exactly, we don't really have much acid rain like as it's known in the park. Just because the air quality here is actually really good. And so that's actually something that we're not too impacted by, but even just the regular rain as it falls, it has enough that over time it breaks the rocks down. So that's sort of our fun little example. And again, that's the chemical weathering component, and again, that ice is the physical weathering component. So we have then carved our geologic cake into what we call hoodoos. The process as it occurs, think of it, so this is east to west. So the erosion is occurring east to west, but it's easier to explain west to east. So first you have these walls or fins sticking out of the plateau. Then next step, you get a window that's created in the fins. That's from all that ice breaking the rock apart from the middle first. You're left with the window. I kind of wondered why we don't look more like Arches National Park then, a bunch of windows in the rocks. That's because the mostly limestone that we have here, it's a lot weaker than the sandstone that's at Arches. So Bryce Canyon's rocks can only support the window shape for so long before it becomes too top heavy and just breaks away. And then that's how we're left with our hoodoos. So when you look across, you can kind of follow it. Plateau, wall, window, and then hoodoos. So when you're out exploring, just take a look, see if you can find that process occurring elsewhere. And I have accidentally referred to it as a canyon a few times. Bryce Canyon is actually not a true canyon. True canyons need to be carved by a river or a stream. So this is referred to as a geologic amphitheater because it's mostly the frost wedging taking place as well as the chemical weathering eroding it. Here at Bryce Canyon, we are fortunate enough to have the highest concentration of hoodoos found anywhere in the world. So just like a precious family recipe that we want to pass down to future generations, we want to pass down Bryce Canyon to future generations as well. So please remember to stay on the trails, throw your trash in the trash cans, and we can enjoy this for the next 25 million years. So thanks everyone for coming, and I'll be up front if you have any questions.
Thank you.